Never collaborate with more than 3 people. That's my new rule.
or if you do, don't be the lead author.
That's it. Yeah, I'll go along. I'll tag along with anybody who wants to have hundreds of co-authors again.
My name's Corey Bradshaw from the Environment Institute at the University of Adelaide. Working with Bill Laurance on a paper called Averting Biodiversity Collapse in Tropical Protected Areas.
And the basic idea of the paper is that, you know, we live in this era of incredible destruction and degradation of tropical forests, and it's becoming increasingly obvious that a real cornerstone for our future efforts to conserve nature are going to be protected areas. Okay. Probably the most important conclusion from this study is the importance of threats around protected areas. It's not just what's happening inside the protected areas, it's the variety of different kinds of environmental perils happening outside, because they have a very strong tendency not only to fragment the park, to isolate the park, to create all kinds of problems with the park itself, but also frequently they penetrate inside to the protected area itself. So there's this eternal external threat, and we have to be very aware of that. We ignore it at our peril and at the peril of biodiversity. And what really became obvious, I mean, if you sort of look at the papers that are being published right now around the world, we're becoming extremely clever at seeing the world from a bird's eye view. We have all these sophisticated satellites and airplanes and other kinds of remote sensors. But what's obvious is that that information, all that incredible imagery, which is very useful, but it's not really telling us what's happening on the ground. It's not telling us about the monkeys in the forest, or the forest rhinoceros, or the hornbills, or whatever kinds of species are out there, and whether or not these major biodiversity groups are really able to persist in the future. But really, that's the main motivation behind this work, is trying to ask, why is it that some protected areas are working? Why is it that some of them are not working? What's really happening on the ground above and beyond what we can get from looking at them from outer space?
Yeah, Corey?
Yeah, I just wanted to add too that, as someone who works a lot with satellite imagery, and you can get some amazing detail now, even, with things like LiDAR, which is basically like a laser you shoot down from a satellite or up from a base station, and you can measure even the height of trees. That kind of detail is amazing, but still, as Bill said, it's not going to tell you about the invasive species on the floor of the forest that are coming in. Lianas, all sorts of things that aren't meant to be there. It also doesn't tell you much about the trends of the species underneath that canopy. So you can infer a lot about species loss from looking at gross changes in habitat area, so forest area. The famous species area curve, for example, allows us to predict extinction rates, and that's really why we know now that we are in an extinction crisis. But it doesn't tell us really how much or how long that takes, or as Bill said, it doesn't really tell us if the what we call the matrix, which is this sea of threat that surrounds all these islands of supposed pristineness, isn't in fact just creeping in and munching away at the very core of these reserves, and that's what we're trying to test.
Yeah, and it's also important to understand. Another thing I suppose that motivated me in about 4 or 5 years ago now to start this study was understand or getting this very strong sense that when you tried to figure out which biodiversity groups, is it monkeys, is it old growth trees, is it freshwater fish, whatever, which groups are really the most vulnerable in protected areas. And what you realized was that, in one particular area there might be a lot of data, but in so many other places there wasn't anything, and the data weren't comparable. And it was just so hard to try to make any kind of general conclusions about anything, because everything was so hodgepodge and mixed up. And so one of the key motivations behind this was to try to understand, as we've been talking about here, some of these forces that are potentially threatening, imperiling protected areas. And it's also trying to understand, are there certain groups of species that are especially vulnerable? And, are those things that we need to be especially worried about? So that was part of the motivation too. This study is based on expert interviews. It's based on 262 very detailed expert interviews. These poor experts, by the time we finished with them, we'd sort of sucked dry every morsel of information that they had in their being, which is why also, by the way, most of them are collaborators on the paper. But we had to develop quite a rigorous protocol because interview data do suffer from certain weaknesses or certain risks, and you have to assess those and critically evaluate that information. And so we spent quite a lot of time talking to social scientists, reading the survey literature, and thinking about the methodologies, and then also thinking about the quantitative analysis. And of course, that's where Corey really played an instrumental role. Is he's very strong at quantitative analysis, and also he's had a lot of experience with high-level publishing. And so I think that's where I found Corey especially valuable. Even among the 216 co-authors on this paper, Corey was probably my main go-to guy because he's a very good quantitative thinker, and he also knows how to publish in the top journals. So you really need a lot of times of anguishing over things and wrestling with things, and Corey was a guy I was always calling up and saying, what do you think about this?
And how many fights did we have over words?
Well, we had a few.
We had lots of language issues and how to best present these things. And I think what was fascinating for me is I hadn't really worked with interview data before. And Bill mentioned it, but I mean, the fact that we had to go to the interview data, it was because there was no way on this planet in this lifetime, 20 lifetimes, that you would ever manage to get the kind of knowledge that was packed into the brain of an expert. The problem was extracting that information with the least amount of bias, because everyone's got their beliefs and their biases and all that sort of thing. So part of the scientific method was to try to tease those away from the biases and try to mix things up so that it wasn't just someone's opinion. And again, the first time we had it refereed, that was the principal concern, is that, it's just interview data. It could be anyone's, you may as well just be making things up. Well, I think with breadth of the interviews, the depth of the interviews, and then the cross-validation with some of the data sets that we actually did have access to, even that validation data was so incredibly rare, but it did support all of the trends that came up in the interview. And my job was basically to try to make that as objective as possible through simulations and randomizations and various other things that help us tease apart those or get rid of those biases as best we can.
Yeah, it really was an exercise in trying to separate the wheat from the chaff, and I'm pretty happy with the analysis at the end of the day. I feel like it's as robust as we could make it under the circumstances. And I sometimes joke around when I give this as a seminar. I talk about this. The study is based on bad data. And then I say bad stands for best available data, and really I think we did really the best we could to gather and glean the available information that was out there, and then to try to interpret it in the most robust way possible. It's always going to be possible to improve an exercise like this, but I think the fact again that it's being published in Nature tells you that it's being perceived as being a pretty important analysis, and that it's very sweeping in terms of its breadth and depth, and there's really nothing else out there that's quite comparable with it.
You start. I think, Bill, you should probably talk about how you got all these bloody people together and managed to organize this, because I've never done that in my life. It was
all right. Well, prior to this, the biggest paper I'd ever worked on in terms of number of collaborators was 55, and I swore after that I would never ever take on another paper that had dozens and dozens of co-authors. But this thing ended up with 216 different co-authors, and really it came down fundamentally to the fact that, as I said, we had these brutal questionnaires. I mean, 10 pages, up to 365 questions, an open-ended telephone or face-to-face interview. People were really suffering by the time they'd worked through this interview process. It was not an easy exercise getting through this. I mean, trying to get, scientists are like cats, and we're trained to disagree, and we're trained to be very opinionated. And, out of those 200-odd co-authors, there's probably about 80 of them that had, at one time or another, had really strong opinions about one thing or something else. And so you're trying to herd 216 cats in one direction and get everybody to agree. Well, I think initially when this started off, we had a good team. This started off when I was with the Smithsonian Tropical Research Institute in Panama. I had a good team of interns and other people, research assistants working with me there. So there were some really good people that were engaged in this initially. You couldn't have done this. You needed substantial person power in order just to get all these interviews. And it also wasn't just a matter of doing the interviews. In some cases, we really had to chase people you know, in some cases, we really just had to harangue these people. I mean, I think we even got to the stage, in some cases, calling people at home and just got to the stage where we were just so annoying, they finally gave up and said, okay, I'll do the interview, because it was just easier to do it than not to do it at some point. But it was not easy tracking all that down. It's so good to be able to talk to Corey about a lot of the quantitative analysis and think critically about this, because it's just, you know, lots of challenges, and there's no magic way to do this, and you have to kind of struggle through and figure it out. Corey is a statistical Nazi. In case anybody doesn't know this about him, he has very strong opinions about some things, and he has very strong opinions about how you should word certain things, which I don't always agree with. So maybe our most interesting conversations were about how one words it. But if he's a statistical Nazi, he's my favorite statistical Nazi, and he certainly knows his stuff. So I've got great respect for him.
Yeah. So talk a little bit about the mathematics, Corey. Yeah. What was straightforward and/or challenging with regards to analysis?
Well, first I want to say, and thanks for Bill for inviting me on board to this, because, you know, with the amount of work that he'd already done, it was multiple steps, and usually they're all fairly small, simple steps, but in the end they built that story. And I guess it's like crafting the paper in essence, only with the numbers. You start very generally, and then you work down to the detail, and then you start to piece it all together and make it into a nice shape. So
that a lot of our head scratching, I think, had to do with, you know, how do you make the best of an imperfect situation? What's the most robust way to do this, most defensible way to do this, and yet still, you know, analyze the bulk of the data. And as Corey said, there was something like 3,500 different comparisons that are sort of implicit within this paper. If you look at every combination of factors that was actually compared at one point or another, but obviously that had to be distilled down greatly into a Nature paper, because those are just a couple thousand words. I don't know how else, honestly, you could probably have attacked a problem like this. We needed a big team effort. Gave us the benefit of a huge amount of very hard-won knowledge that they'd picked up over decades of time. And so we're really appreciative to them. And I think just the bottom line for me is happy and relieved to finally get this thing in press with Nature, and I'll be delighted to see it finally go out and see the light of day. There's certainly been a lot of blood, sweat, and tears that went into finally seeing this thing come to fruition.
Fantastic. Corey, Bill, thank you very much for your time.
Thank you very much, Mike.
Thanks, Mike.